everyone can see the screen you have in your okay, yeah, I see some thumbs up. So you can show me thumbs if you need if you understand the thing, or please raise your hand if you have any question. So let's start. This is first question. I would really recommend you to work with me. So try to do the question at the same time I do. Get your calculator. Try to do the questions before I do them. Hello, Ariana. This one, super simple question. You have line L has this equation, line L2 has this equation, M is a constant. You all know that is the gradient. Yeah, when we have the equation in this form, this is the gradient, this is the y-intercept. Given that L1 and L2 are perpendicular, we have to find the value of M. You know that when two lines are parallel, the gradient is the same. When two lines are perpendicular, the gradients are negative reciprocal of the other. So we are able to find the gradient of this one. The other one is going to be negative reciprocal. So please try to find the gradient of that line. I know you are going to be faster than me. So I'm going to make y the subject. Rachel, hello, we are just starting. I'm going to make y the subject so I can do it easily. So I have y divided by 4 is 3/4 minus 2 divided by 4 is 1/2 of x. This is the gradient of this line. Yeah, the gradient of this line is minus 1/2, which means the gradient of the perpendicular is going to be negative reciprocal. The gradient of the other line, the perpendicular one, is going to be 2. So negative reciprocal. And that's what they asked me in the first part. Yeah. Then lines L1 and L2 meet at the point P, and we have to find the x coordinate. Remember that sometimes they are going to ask us the coordinates in plural. That means we have to write both of them, the x and the y. In this case, they just ask x. Don't waste time finding y. Yeah, you don't want to waste time in your exams. So B, how I'm going to find where the lines meet? Always solving simultaneous equations for any type of lines. These are straight lines, but it could be a quadratic, a cubic, a circle, wherever. So I have one line that is 2x plus 4y. So line 1 is 2x plus 4y minus 3. Please do it with me. And the other line is y is 2x, because I now know the gradient, plus 7. And I just solved simultaneous equations. How you solve simultaneous equations is up to you. But please show some working out. Yeah, don't get the calculator, solve the simultaneous equations and write x and y. Even if you do that, to be sure that you have the answer correct, do something else. Yeah, I'm going to substitute this y into here, which means I have 2x plus 4, and instead of y, I'm going to write 2x plus 7 minus 3 equals 0. Then I expand the bracket. Hello, Lily. Expand the bracket and find x from here. Yeah, so I have 2x plus 8x is going to be 28 minus 3 is 25. Goes to the other side as negative, which means that x is going to be minus 25 divided by 10. So you can write minus 2.5, or you just simplify. So you can write x is 25 divided by 10, or 5 halves, minus 5 halves, sorry. Either way, they don't ask us in a particular way, so either way. Is the question clear so far? Please show me thumbs if you, or stop me if you have any question. No? This one was easy, right? Another one. So find, using algebra, all real solutions to this equation. So we have an a squared, square root of a. So I think every time you have a square root in the equation, I will leave it alone in one side and then square both sides. Actually, you can even simplify. You can divide the whole equation by 2. So you will have already your a square root of a alone. Yeah. Now we square the whole thing. If we square the whole thing, this would go squared. This would go squared, so I have 64 a to the power of 4, and square root of a squared is going to be a. Yeah, I know it's very tempting to cancel this 4 with the a and write 3, but if you do that, you would be missing one solution. And you see the solution? The solution would be a equals 0. Yeah. So if you are trying to simplify numbers, it doesn't matter. You can cancel it. You have 2 and 2 squared, the square with the 2. If you are trying to simplify variables, you have to think that that variable can be 0, and that would make true your equation. Yeah. So this is one solution. So simplify, but don't forget about that solution. So then I have 64 a to the power of 3 is going to be 1, which means a to the power of 3 is going to be 1 over 64, which means doing the cube root that a is going to be cube root of 1 over 64. That is what? 4. Let me do it. 4, yeah. So it's 1/4. Yeah. So a can be 0 or 1/4. Don't forget this solution. Don't just cancel the variables. Every time you cancel the variables in the equations, you are missing one solution. Yeah. Hello. Second part. It says b to the power of 4 plus 7b squared minus 18 equal to 0. You don't know how to solve quadratic equations, but you know that when you have something and then the same something squared, you can work with a quadratic. So you have something that is b squared, and b squared is b to the power of 4. So really you can see this equation as x squared plus 7x minus 18 equal to 0 when x is b squared. Yeah, it's a way of calling b squared x and seeing an equation that is simpler. So we can solve that equation. I will recommend you for the quadratic equations, unless you see them super quickly and very easily, to use the calculator, because in the exams, when you are nervous, you make them, well, you and me, anyone, make very, very silly mistakes. And that's a shame. So I have x plus 9, x minus 2, equal to 0. So my solutions are x equals minus 9 and x equals 2. But I'm not looking for x, I'm looking for b. And I know x is b squared. So this is going to be b squared. That would mean that b would be the square root of minus 9. So this is not possible. This is not giving me any solution because b squared cannot be minus 9. Yeah, so this one is not giving me a solution. This one is going to be b squared, which means b is going to be plus and minus the square root of 2. So I have two possible values of b, which are root 2 and minus root 2. Yeah? Is the question okay? If you see anything that doesn't sound well, tell me, because maybe I'm doing something wrong. Okay, excellent. Okay, another one. These ones are the easy ones. There are a couple of more difficult at the end, but the paper you see that is not too bad. So given that k is a constant here, we have to find this integral. So please try with me. Remember to integrate, we are going to write we want our expressions to look like x to the power of something. So if I have the x dividing, it's better to write this expression as 4x to the power of minus 3 because it's going to be easier to integrate. Yeah. So let's going to do that. We have the integral of 4x to the power of minus 3 plus kx dx. And when I integrate, remember the exponent goes up by 1 and I divide by the new exponent. So I will have 4, and then the minus 3 goes up by 1, so minus 2 divided by minus 2. And then the kx, the x goes squared and divided by the new exponent. And don't forget the c. because in some questions it will say condone the missing C, but in some questions you will miss a mark for not writing the C. So try to remember. I understand if you forget. I forget it. And it says simplifying your answer, which means we are going to work a bit the coefficients. And if you want, you can leave this x as negative or bring it back to the denominator. It doesn't matter. What they want is you to simplify the coefficients, really. So this is minus 2 divided by x squared plus k x squared divided by 2 plus c. Yeah? So this is this first part of the question. Yeah? Then B, it's a hence. Every time you read hence in the question means using what you just done. Don't do extra work. It's going to simplify your question if you use what you did before. Yeah, we have to find the value of k, such as the integral, definite integral between these two values, give me 8. Yeah, so try to think what we are doing. What we are going to do is the integral between 0.5 and 2, we already found the value, the expression, so we are going to substitute the 0.5 and the 2. So I have minus 2 divided by x squared plus k x squared divided by 2, and I'm going to substitute the 0.5 and the 2. Remember always the top one, and then minus, I substitute the bottom one. And I would recommend you to write brackets because it's very easy to make mistakes here with the signs. Yeah, I substitute the 2 and I have minus 2 divided by 2 squared plus k times 2 squared divided by 2. This is when I substitute the 2. Yeah, the minus, I substitute the 0.5. So minus 2 divided by 0.5 squared plus k 0.5 squared divided by 2. And this is when I substitute the 0.5. This is going to be in terms of a, and then I'm going to make it equal to 8 to find k. Yeah, I'm going to do it, but please do it with me because just in case I get that completely wrong. If you get the answer, please type it in the chat if you want. Yeah. So I have, well, I'm going to go step by step because we have the k there. So we have the minus 1/2 here plus 2k, then minus minus is going to be plus 8 and minus 0.5 squared divided by 2 is 1/8. So minus 1/8 of k. Yeah. So I have 15 halves. I'm just putting together the numbers and the k's. Yeah. 2k minus 1/8 is 15/8. So plus 15/8 of k. And this is going to be equal to 8. Yeah, I have worked with the expression until I cannot simplify more, and then I'm going to make it equal to 8. You can make this equal to 8 before and then work with the whole thing. It doesn't matter. Yeah. So I have. So you have 8 minus 50 is 1/2. No? 1/2. So it's 15 over 8k, and then 8 minus 15/2 is 1/2, which means that k is no, I'm doing something wrong, sorry. 4 over 15. Yeah, I hope you get the same, and I hope you're doing it with me. Did you get the same? Okay, cool, perfect. So that's the value of k, and the only thing that we've done is using the expression that we found for our in integral, and then substitute the limits. So first you substitute the 2, then minus, you substitute the 0.5, and you're super careful with the signs, because if you don't write the bracket, sometimes we make mistakes with that. Okay, all good with this question? Perfect. The next one. This is a straight line question, but it's a modeling question. And I know the modeling questions are always a bit, they are a bit scary for the wording, but usually they are easier than other questions. Yeah, so you just have to understand what is happening. So you have a tree was planted in the ground. The height H meters was measured 3 years after planting. Exactly 3 years after planting, the height is 2.35. Exactly 6 years after planting, the height was 3.28. Yeah? Using a linear model, find an equation linking H with T. So what we're going to do is to write H, and if it's a linear model, it's going to have the equation of a straight line. So I'm going to have something like A plus BT, or if you want to think that you're doing this, C plus MX, yeah, gradient and y-intercept. You can swap the letters, but the Y is the H and the X is the T, because the height of the tree depends on the number of years that has been planted. Yeah, so this one depends on this one. The height depends on the is function of the time that it has been planted. Yeah. And now we have to find the constants. So these two are the variables. Don't get confused because there are too many letters here. And A and B are constants. It say exactly 3 years after planting. So when T is 3, the height is 2.35. So 2.35 is A plus B times 3, or 3B. And then the same, 6 years after is 3.28. So we're just going to solve these simultaneous equations to find A and B. Yeah? Again, how you solve them, up to you. If you use the calculator, still you have to solve some working out. I'm going to subtract them so I can get rid out of the A's. Yeah? But I'm going to subtract this one minus this one. Yeah? So I don't have negative things. So I have 0.93 equal to 3b. Therefore, b is 0.93 divided by 3, which is 0.31. No, that's the b. And now the a, from here or from here, I just substitute the b and find a. Yeah. So if I go, for example, to the first one, I have 2.35 is going to be a plus 3 times 0.31. So a is 2.35 minus 0.93, no? Which is 1.42. They don't ask me this constant, they ask me the model. So don't forget at the end to write the expression that links H and T. Yeah, so I have to write something like H is A, which is 1.42, plus B, which is 0.31 T. That's my model. Yeah. Oh, sorry. And usually when they ask you to find a model, then they ask you questions about it. So sometimes they ask you how the height of a tree after 2 years or 10 years, or the other way around. What is the height of the tree when it was planted 20 years ago? Yeah, so they are going to ask you to use the model, which is what happens here. So they say the height of the tree was approximately 140 centimeters when it was planted, and explain whether or not this fact supports the use of the linear model. We are deciding if the model is okay or not. So what we can do is to find the height of a tree when t is 0, because when it was planted, t is 0, yeah? And compare with the height of the tree, yes? Or substitute the height by 140 and see what t is. But I think it's easier to substitute t by 0 because the equation becomes easier. So when t is 0, in our model, we have that the height is 1.42 because this is 0. 1.42 meters, yeah, because we were working with meters. And 1.42 meters is 142 centimeters. So this is in meters, which is 142 centimeters, which is very close to the 140 that they say. Yeah. So your conclusion should be that the model is okay because this is quite close. Yeah. So something like the model is adequate, or the model, what do they say? Works well as the initial height is very close to is very close, yeah, to 140 centimeters. The calculated one with the model. Does it make sense? Can you tell me if the question is clear? Yeah? No questions? Okay, another one. This one. Curve has equation. This one is, we have to find in the simplest form dy by dx. Again, like with integration, every time you have an x in the denominator or a square root, it's quite helpful to write it in the numerator. So we really want to have x to the power of something because that's what we know how to differentiate or how to integrate. So we are going to write this as 24x to the power of minus 1. Yeah, that's going to be helpful. So let's derivate. Remember, when we differentiate, exponent goes to the front multiplying the coefficient and the degree goes down by 1. So in this case, these two goes multiplying the 3, so I have 6, and x squared goes down by 1, so x. And then I have this exponent minus 1 goes multiplying the 24, so minus 24, and the x goes down by 1. So instead of minus 1, minus 1, minus 1, minus 2. Be careful with that. And then when I differentiate a number, is 0. Yeah. So this is my derivative. It says in the simplest form, this is the simplest form. If you prefer to bring back again the x to the denominator, that's fine. If not, that's fine as well. Yeah. B, hence, we are going to use that. Find the exact range of values for x for which the curve is increasing. Do you remember how we check if the function is increasing? So a function increasing is a function doing this, going up. Yeah, that's an increasing function. For that function, the gradient of the tangent is positive. Yeah, so the way of checking if the function is increasing is checking if the derivative is positive, because the derivative is giving me the gradient of the tangent. Yeah, so the function is increasing when dy by dx is positive. Yeah, sometimes you will see equal or greater than 0. So let's going to see when that happens. So we have the derivative, which is this function here, and we want to see when this is positive. Yeah, so please try to do it with me. You have to be very mindful of what you multiply by when you have an inequality like here. Here, to get rid out of the denominator, I'm going to multiply by x squared. X squared is always positive, so it doesn't matter. But if you have here an x, be super careful, because if you multiply by x, if your x is positive, it's okay. But if your x is negative, this will change direction. Remember, when I multiply an inequality by a negative number, the sign is flip. Yeah. So instead of greater will be smaller, instead of smaller will be greater. Be super careful with that. In this case, it doesn't matter. I'm going to multiply by x squared. So I have 6x cubed minus 24 must be greater than 0. So 6x cubed must be greater than 24. So x cubed must be greater than 4. And therefore, x must be greater than cube root of 4. Yeah? And that's the exact, and when they say the exact range, every time you see the exact answer, the exact value, the exact range, something like that, what they mean is don't use the calculator and leave it in terms of a square root, of a logarithm, an exponential, a fraction. Don't simplify, don't divide, don't give decimals. Yeah? So that's the range of values. The function is increasing when x is greater than the cube root of 4. Does it make sense? Do you remember this? Everyone? Okay, excellent. No questions, please. If you have any questions, stop me and ask them. So another one. We have a triangle here. AB is 3x, AC is 2x, and the angle is 60 degrees. Given that the area of the triangle is 18 root 3, we have to find x. Yeah, they give us the value, but we have to find it. So think, how can we find the area in these type of questions? Remember, we have a formula, and it's not in the formula booklet, so you have to remember that the area of a triangle is 1/2 of AB sine of the angle between A and B. Yeah, so in this case, the area is going to be 1/2 of one side, the other side, and sine of the angle in between those sides. Yeah, so we can write that the area is going to be 1/2 times 2x times 3x times sine 60. And this is going to be equal to 18 root 3. Yeah, we can simplify a bit here. So sine 60 is root 3 divided by 2. No? So we have 3, this 3, x times x squared. Sine 60 root 3 divided by 2 must be equal to 18 root 3. We can cancel the root 3. And we can simplify the numbers. So we have x squared is going to be 12. Yeah, 12, which means x is going to be root 12. Cannot be negative because it's a distance. So remember that when you are doing the square root of something, you can have a positive value or a negative value. Not always you are going to be able to leave both. So if the value cannot be negative because it's a distance or it's time when you're working in mechanics, just pick the positive one. And this is, remember, root of 12 is root of 4 times 3. I can get the 4 outside, so I have 2 root 3. Yeah, so this is 2 root 3, which is what it needs to be. Yeah, so that's the value of x. And we have done it using this formula. Yeah, that is not in the formula booklet, and you have to remember, but you have been using it for years. Then B, say hence. Again, we are going to use that. Find the exact length of BC. So BC is this side here, this side. Yeah, we know x, and even if you are not able to do this part A, you know x. So please don't skip the whole question when you don't know how to do the first part, because you still can find easy bits after. Yeah. So 3x, if x is 2 root 3, is going to be 6 root 3. Yeah, just multiplying 3 times 2 root x, and 2x is going to be 4 root 3. We know two sides and one angle, and we need the other side. Remember, you have two rules that you can use with the triangles to find angles or sides, are the sine rule and the cosine rule. Sine rule, I need two sides, two angles, or I need to find one of them. Here, for the cosine rule, I need three sides and one angle, and that's what I have. So I have one angle, and I need one side, and I have the other two. Yeah. Remember the cosine rule. The side that you have a square on its own is always the opposite to the angle that you are working. So if this is A, you will have A squared is the other two, so B squared plus C squared minus 2BC cos A. Yeah, so if you're using cos A is what is alone. And again, this is not in the formula booklet, so you cannot mix the things because then it gets wrong. Yeah, so I'm going to call A squared to the side that I'm looking for. So A squared is, let's say, this one squared, so 6 root 3 squared, plus the other one squared, that was 4 root 3 squared, minus 2 times 6 root 3 times 4 root 3 times cos 60. And from here, we should try to find A. So please do it with me and see what we get. So, do you have a value? I'm doing something wrong. Wait, I'm going to do a step by step. So this is 18. 48. And then I have root 3. Root 3 is 3. This is 144. Cos 60, which is 1/2, no? So this is 18 plus 48 minus. I'm doing something wrong because I get a negative number. Have you found a number? No, it's okay. So this is 72. No, I get a negative number. What I'm doing wrong? Can someone see what I'm doing wrong? So a squared, I need a positive number because I'm doing the square root. So it's 6 root 3 squared and 4 root 3 squared. And then 2 times both sides. I don't know what I'm doing wrong. Dun, dun, dun. If someone sees what I'm doing wrong, please tell me. Minus 62. Rather than 18. Yeah, true. It cannot be 18. It's 108. You're right, because it's 36 times 3. Okay. Thank you. Thank you, Cody. So I have 108 plus 48 minus 72, which is 84, and then I'm doing the square root of that. So a is going to be 2 root 21. Yeah, it was that, definitely. Perfect. Any question? No? All good? So next one. We have used the sine rule, no, the cosine rule, and just the area of the triangle. Sometimes you will need to use the sine rule. So these questions are usually combined. This one. So curve C has this equation. This is a reciprocal. Yeah, remember the reciprocal graphs. K is a constant. Sketch C stating the equation of the horizontal asymptote. Remember the reciprocal graphs have 2 branches and always have asymptotes. If k is positive, my graph is here. When k is negative, my graph is here. When I have an x squared and k positive is here, and when I have x squared and x negative is here. So we have 4 possibilities, and sometimes you mix them. So my recommendation is, if you're not 100% sure, check a value. So ignore so far the one, just to decide in which quadrant it goes. So this one is always positive because it's squared. And when x is 1, the y is 1, so it's in this quadrant. When x is minus 1, the y is minus 1, so it's in this quadrant here, yeah? So it's here and here. And I would check just with easy values, 1 and minus 1. That's your graph of k squared divided by x. So if you represent just k squared divided x, you have this graph. This is x, this is y. Your graph is doing something like this. This is k squared divided by x. But what you are doing is adding 1 to the y. So you are doing f of x plus 1. Remember the transformations? I am adding 1 to all my y's. So all my y's are going up by 1, which means this is my asymptote is going to go up by 1, and the whole thing is going to go up by 1. So my graph, which is not this one, obviously, is going to have an asymptote in the 1. So it's going to have an asymptote here in the 1. This is 1. And it's going to do something like this in this side. And in this side, something like this. It's going to cut my x-axis, and that's fine because now my asymptote is the blue one, not the x-axis anymore. When you represent graphs that has asymptote, please be careful of not drawing and touching. Yeah, so please don't do this by accident or just because you do quickly. It has to be clear that they are asymptote and they don't touch. Yeah. So this is your graph. And they say, stating the equation of the horizontal asymptote, which is y equal 1. Yeah, so that's the asymptote. It's okay? Sorry, asymptote. The line L has equation y equal minus 2x plus 5. We have a straight line. Gradient is minus 2. Y-intercept is 5. So it will be, I don't know, something like this. Probably, yeah, it depends on the gradient. So this is 5, and the gradient is minus 2. So I have that line. And it says, so that the x-coordinate of any point of intersection of L with C is given by a solution to this equation. We did a very similar question at the beginning. Intersection between two lines, we are going to solve simultaneous equations. In this case, our two lines are not straight lines. One is, the other is not. But what we are going to do is the same. We are going to solve simultaneous equations, yeah? And when we work with the simultaneous equations, you are going to see that we are going to get this expression here. So my line is y equals k squared divided by x plus 5, that's 1, and the other one is minus 2x plus 5, no? This one is plus 1, plus 1. And I can solve them as I want, it's up to you. I'm going to make the y's equal, so I'm going to equate the equations. So this one equal to minus 2x plus 5. And you are going to work with this expression until it looks like this one. So we have everything in one side. That's what we're going to do. So we multiply everything by x. I have k squared plus x is minus 2x plus 5. So k squared plus 3x minus 5 equals 0. Just reorganizing, yeah? No, I have 4 k squared plus 3x k squared x plus 1. So I make the y's equal to each other. I multiply this. I'm sorry, I didn't multiply these ones by x. So we have k squared plus 2x squared, and then minus 5 plus 1 minus 4x equals 0. Yeah, and that's the expression that we have to find. This one is just in a different order. Yeah, it comes just to making equal both equations to find the points of intersection. And then hence, so using that, proceed, find the exact values of k for which L is tangent to C. So this one needs to cut in one point. So we need only one point of intersection. And the points of intersection are given by this quadratic. And we know when a quadratic has one solution, two solutions, or no solutions. So that's what we are going to use. We are going to use the discriminant, right? Remember? So if I'm solving 2x squared minus 4x plus k squared equal to 0, b squared minus 4ac, which is the discriminant, is going to be equal to 0 when I have only one solution. And remember, if it's tangent, it's going to touch in only one point. So if I have my curve, I can have two solutions, one solution if it's tangent, and no solutions if it doesn't touch. Yeah, so we are in the situation where we have one real solution. B squared is this value squared. So is the minus 4 squared. minus 4 times a, which is 2, k squared, which is 3. Yeah? And this must be equal to 0. And from here, I'm just going to find the value of k. So I have 16 minus 8k squared equals 0, which means k squared is going to be 16 divided by 8, which is 2. So k can be plus or minus root 2. I don't know if we have a limitation for k. It say k is a constant. They don't say, because sometimes they say it's a positive constant, it's a negative constant. They don't say, and they say the values in plural, which means we are fine because we are given 2. And it says the exact values, which means we are not going to find the square root. Yeah, we just leave it this way, plus and minus root 2. Any question? You see what we've done, everyone? Or you are more confused with this question? Okay, I see many thumbs up. Okay, excellent. Please, if not, ask me. I can, I don't know, explain in a different way or something. Question 8. We have find the first 3 terms in ascending powers of x of this binomial expansion. So we have for a 2 plus 3x over 4 to the power of 6. Yeah, and remember you have a formula in the formula booklet. I'm going to show you the formula. Is this one. For year 13 students, you know you have a formula for year 12 questions where this exponent is natural, and another formula when the exponent is not natural number, yeah, a real number. So in this case, we have to use this formula, and that's what we are going to do. So we are going to write, the first one is the first term, which is 2 to the power of 6. Then we do 6 chooses 1, so this one, 6 chooses 1. The exponent of the 2 goes down by 1, so 5, and then I include the second one. So 3x to the power of 1. I'm writing the 1, you don't need to write it, but just to remind you that always this exponent must add up to 6. Yeah? And the next one would be 6 chooses 2, 2 to the power 1 less, 3x over 4, 1 more. Yeah, they ask us the first 3 terms. Yeah, so I'm going to stop here, but if not, you would carry on. 6 chooses 3, these go down by 1, 3x over 4, 1 more, and so on. Yeah, you can write them all. Usually they don't ask you all, they ask you 3, maximum 4, no more. And this is, so in your formula, you have an a plus b, so 2 terms. Yeah, here, this is your a, and this is your b, together with the sign, together with the coefficient, everything. So if it's negative, please keep the negative here in your brackets. Yeah. And now with the calculator, just going to work out the coefficients. Huh? So we do 2 to the power of 6, which is 64. So this is equal to 64. And then remember, we do this with the calculator. You do 6 chooses 1, which is 6. And then we do 6 times 2 to the power of 5 times 3/4, which is 144. So plus 144 x. And then this one is 6 chooses 2 with the calculator again, times 2 to the power of 4 times, be careful because these 3/4 now goes squared. So I'm going to multiply by 9/16. And I get 135. Yeah, plus 135 x squared. These are the first 3 terms of this binomial expansion. Yeah, all clear? It's just using the formula and knowing how to use the formula. And I would say be very careful, mainly when you have negative numbers, of writing the brackets. I know it looks like, well, I don't need to do that, I can cancel straight away, but then is when the mistakes come. I think I would keep things slow. I wouldn't skip steps. I would skip steps in other questions, not in this one. Okay, given each term in its simplest form, just mean write this and not this. Yeah. B. Explain how you could use your expansion to estimate the value of 1.925 to the power of 6. You don't need to perform the calculation. So don't waste time. Yeah, it's just 1 mark and they just ask you how to. Remember to do these questions. They are going to give us always a number to the same power that I have here. So what I always do is to make the bracket of the binomial expansion equal to the number that I have. Yeah, so I'm making this equal to this. I'm find x, and when I have x, I'm going to substitute in my expansion. And it's an approximation because I just have the first three terms. If I have the whole thing, I would get the actual answer. Yeah, so that's what you have to explain. And in fact, the best way is finding the x and specify saying, I find the x is this, and then I substitute in the binomial expansion, but then don't substitute. But I will find the x, I think. Yeah. The x is minus 0.1, which is quite a common x for these questions. These questions, when you find x, usually is going to be a very small number, 0.1, 0.01, 0.5, because when you use your approximation, these powers to the power of 3, to the power of 4, when the number is smaller than 1, they are just going to be smaller and smaller. So they are going to be actually very good approximations. Yeah. So what you have to explain is you are going to substitute x equal minus 0.1 in the binomial expansion that you found in question 1. From part A. And that's it. That's the only thing you are going to do. And if you have to do the calculation, you substitute here and then you find a value with the calculator. My recommendation is that you check your answer. And the way of checking your answer is doing this with the calculator. The calculator can do that. You are approximating because it's an exercise, but not because you cannot do it. So calculator and compare the answers. They are going to be super, super close. And if they are very different, is that you have done something wrong here. So it's a very good way of checking if part A is correct. Yeah. All good with this question too? Any question? No? Okay, excellent. More questions. This one. A company started mining tin in Riverdale on the 1st of January 2019. This is not a difficult question and it's not even many marks. You find it a bit confusing because it's a modeling question and the modeling questions are always a bit, so try to not get scared by them. A model to find the total mass, and this is important, of tin that will be mined by the company in Riverdale is given by this equation, where T tons is the total mass of tin mined in N years after the start of mining. Using the model, calculate the mass of tin that will be mined up to 1st of January 2020. So this function here is giving us per year the amount of tin mined since this year. So it's like cumulative. Yeah, it's not the amount in 1 year or no, it's what they have been mining from 2019 up to wherever you are calculating. Yeah. So it says calculate the mass of tin that will be mined up to January 2020. So 1 year has passed. Yeah, from January 2019 to January 2020. So n is going to be 1. The only thing you have to do is to substitute n by 1 and find t. Yeah. So n is 1 year has passed, which means t is going to be 1,200 minus 3 times 1 minus 20 squared. Do you understand why I'm substituting the n by 1? I get 117 tons. Do you understand why I substitute n by 1? Yeah, because it's 1 year and they are asking me very, very simple question. Then deduce the maximum total mass of tin that could be mined. I hope you see here a quadratic function. So this is like having y equal 1200 minus 3 x minus 20 squared. Yeah, that's a quadratic. If you represent that quadratic, I'm going to represent it because I think it's going to help you to see what is happening. So we have t, this is n in the horizontal axis, this is t. I have one root in the 0. So one root is the 0, 0, and the other root is, I can expand the bracket. I think it's going to be easier to see. So I have 1000 is gone with the 3 minus 3x squared plus 120x. So x is 0 and x is 120 divided by 3, which is 14. So let me show you. This is your quadratic, and this is 14. Yeah, you will think, why are you doing that? It's just to show you what is happening. This is a quadratic upside down, yeah, because the coefficient of x squared is minus, and the roots are the 0 and the 40. What is happening is when the time passes, the amount of tin is going to be increasing until my maximum. My maximum is going to be in the midpoint here, which is 20. You can see that from here because this function is written in complete the square form. Remember, when you have a quadratic written in complete the square form, the maximum is when this bracket is 0, which means x is 20. And when this is 0, y is 1200. So this is the maximum. The maximum is 20 years, and this is 1200. Yeah? They say deduce the maximum total mass of tin that could be mined. So the total maximum total mass of tin is going to be 1,200, and that's because of that. The maximum of this function is when x or when n is 0, and when n is 20, and when y is 1,200. Yeah. So that's the maximum T max. If you want to write, is 1,200 tons. Can you see that? I have a quadratic, I find the maximum. If you don't remember that when you complete the square, the maximum is here, expand the brackets and differentiate the function. You're going to get the same value. Yeah, when you differentiate this function and you make that equal to 0, you're going to get the same value. Or if you find the root, remember the quadratic is completely symmetrical. So if I have a root here and a root here, in the midpoint, I'm going to have my maximum or my minimum. So there are a few ways of finding it. Then, C, calculate the mass of tin that will be mined in 2023. Remember, this is giving us something cumulative. If I substitute, so look, from 2019 to 2023, 4 years have passed. If I substitute m by 4, I'm going to get all the cumulative tin for those 4 years. What I want to do is just 2023. So think, how are we going to find that? What we can do is calculate the cumulative up to 2024 and then subtract the cumulative until 2023. I hope that makes sense. So you have a certain amount up to 2024. You can calculate that because in this case, n is 5. And then you have another amount up to 2023 because n is 4. And what we want is what happens in 2023. And when it happens in 2023 is from January 23 to January 24. Yeah, we are working with 1st of January of each year. Yeah, so it's going to be the difference between M5 and N4 because M5 is January 2024 and N4 is January 2023. Does it make sense? Do you understand why I'm doing that? Okay, so then when n is 4, t is just substituting, is 1200 minus 3 times 4 minus 20 squared. We find that. And I get 432 tons. That is until January 2023. When n is 5, I have t is 1200 minus 3, 5 minus 20 squared. So I have 522 tons. 25 tons, sorry. This is until January 2024, which means the difference is going to be what is produced in 2023. So in 2023, I have 525 minus 432, which is 93 tons. Yeah, because it's in just 1 year, not up to that year. If we substitute just for that year, we will find 2019, 2020, 2021, and so on. Next thing, state giving reasons the limitation of the values of n. So think a bit what happens with the model, and I think the graph is going to help you, and that's why I draw the graph. N obviously cannot be negative. So n must be greater than 0 because it's the number of years that passed since 2019. The years cannot be negative, yeah? And then if you see what happens with the graph after 20 years, and you think that this is the cumulative number of tons, after 2020, this starts to decrease. So it's like I'm bringing back the teen to the mind. So I have less cumulative. It's not the amount that you do every year, it's the cumulative amount. So that cannot decrease. So your maximum is going to be N20, because after 20, after the maximum, it would be decreasing, and it cannot be decreasing the amount that you have taken from the mind. Does it make sense? Yeah, I see some people, not everyone. Do you have questions? Do you want me to explain in a different way? So m must be greater or equal than 0, yeah, because I cannot take negative years, and it has to be smaller or equal than 20. It can be 20, yeah, because still for 20 I have the maximum and it works, but after 20 what happens is I will have less cumulative tons. Yeah. I don't think it's a difficult question. It's a bit confusing, I think. No? More. So let's do this one. I think there are 14, 15. So we are going very well. A circle has this equation. We have to find coordinates of the center, exact radius. That's very, very typical question. Try to do it with me. So whenever you have your circle written this way and they ask you the center and the radius, you have to complete the square with the x, complete the x square with the y, and rearrange. So if you complete the square with the x, I'm going to write the x's together and then the y's, because I think it's going to help you. And just reorganizing the equation, yeah? I'm going to complete the square with this one and the square with this one, yeah? When I complete the square, remember, I divide by 2, look, wherever is multiplying the x, I square it, and then I subtract the number squared, so 4. Why? Because when I expand this bracket, I have x squared minus 2 times 2 for x. Bye-bye, Monet, no problem. And then I subtract this number because it's in the way. I don't want it, yeah? The same with the y. So y plus half that squared, and then I subtract the 4 squared, which is the 16. And then I have my 8. Yeah, don't forget that bit. And now I'm going to reorganize, so I'm going to send all the numbers to the other side. And I have x minus 2 squared plus y plus 4 squared. And then I have minus 28, no? So 28 in the other side. Once I have the equation this way, remember, when I have a circle, x minus a squared plus y minus b squared equal radius squared, the center is AB and the radius is r. So I'm just, from there, I say that the center is going to be 2 positive minus 4. 2 minus 4. And then the radius is square root of 28. Or if you want to simplify, I think always looks better, 2 root 7. Yeah. If you have units, please give units. So we have, no, in this case, we don't have units. But if you have units, you write them. Yeah. Center and radius. Yes. Very, very common. Most of the circle questions start with that question. Find the center and the radius. Then, straight line with equation x equal k, where k is a constant, is tangent to the circle. Find the possible values of k. If you have, I'm going to start with a question that is not this one. If you have a circle and they give you a line y equals mx, I don't know, or they give you the gradient. So let's say 2x plus k, and this one. Or they miss the gradient and they give you the y-intercept. So if they give you a random line, slanted line, the way of finding the values that are missed for being tangent is like we did before with that reciprocal. We can solve simultaneous equations and we can force the discriminant to be 0 because that will allow the line to be tangent. You can do that with this question, but there is an easier way because the line, if you realize, is horizontal. It's horizontal, it's vertical. It's x equal k. So x equals a constant is a vertical line. So what you really have is a circle. The center is 2 minus 4. So the center is 2 minus 4. The radius is 2 root 7. And you have vertical line here and a vertical line in the other side that are tangent. So it's much easier than x equal k and x equal another k. Yeah, it's easier than trying to make the intersection just 1 point. Yeah, so because this point, the x coordinate is 2, wherever the axes are. I'm not going to draw them well for sure. So imagine your x and y axis are here and here. Yeah, x is 2. So the x of this point is going to be 2 plus 2 root 7. Yeah, so the radius is here. So my x coordinates of this point, because really I want the x coordinates of this point, is 2 plus 2 root 7. 2 plus the radius. And the x coordinate of this point is going to be 2 minus this length. And this length again is 2 root 7. So the x coordinate is going to be 2 minus 2 root 7. Yeah, so I can just move my radius to the right and to the left to find that constant. And this is what possible values of, find the possible values of k. So this is 1k and this is the other k, yeah? If you do the other way, it's going to be longer, but you're going to get the same answer. Yeah, it's just, in this question in particular, it's just easier to think and do the sketch. Always the sketches help. Does it make sense? Any question? No question? Perfect. Okay, next question. This one. We have this function, which is a cubic, and it says prove that x minus 4 is a factor of x. You know that you have a theorem to prove that. When you prove that in an exam, and it mainly saying proof, every time you have a proof question, you have to be very careful showing you're working out and explaining what you're doing. I would mention the theorem. So you can say, you remember this is the factor theorem. So the factor theorem says that if f of 4 is 0, when you substitute the 4 here is 0, then x minus 4 is a factor. So what I would do is substitute the 4 here. So you're going to do f of 4. f4 is going to be 2 times x cubed. So times 4 cubed minus 13 times 4 squared plus 8 times 4 plus 48 is going to be 0. Yeah, you can check if you want, but it's going to be 0. Therefore, x minus 4 is a factor. And then you can say something like the factor theorem. Yeah, so mention the factor theorem. So don't get just f4 is 0 and then that's it. Explain. Mainly when it's a proof question, you have to say f4 is 0, therefore using the factor theorem, x minus 4 is a factor. Yeah, something like that. It's a line and I think it's going to get you the marks. Then hence, so we are going to use that. Using algebra, show that the equation fx equals 0 has only 2 distinct roots. This is the graph of the function anyway. So these are going to be the roots. How are we going to find that? We have a cubic. Remember, we don't know well how to factorize a cubic unless very easily we find a factor. And we have a factor. If we divide this cubic by this factor, just polynomial division, we are going to get a quadratic. So every time we divide by x, we are going to get a degree reduced. And then we know how to factorize the quadratic. So that's what we are going to do. We are going to divide by x minus 4, get the quadratic, and then see that the solution that our quadratic has. So let's go into divide. Again, try to divide with me, please. So the function is 2x cubed minus 13x squared plus 8x plus 48. No? And I'm going to divide by x. Oh, I don't have space. I'm going to divide that by x minus 4. So I'm going to write the x minus 4 here. And I'm going just to divide. Please divide with me. So 2x cubed divided by x is 2x squared. I multiply and I have 2x cubed minus 8x squared. I subtract. These are gone. And then I have minus 13 plus 8, which is minus 5x squared. Minus 5x squared divided by x is minus 5x. I multiply minus 5. I don't know why I read 4. 5x squared plus 20x. I subtract. These two are gone. And then 8 minus 20 is minus 12x. Then I divide again. So minus 12. When I multiply, I have minus 12x plus 48. And I subtract. These two are gone and these two are gone. You have to get remainder 0. If you don't get remainder 0, you have done something wrong, yeah, which is not uncommon in these questions. But if this is a factor, remainder must be 0, which means our function is x minus 4 times 2x squared minus 5x minus 12. And what we can do now is factorize this quadratic. And you know how to factorize the quadratic. So I'm going to get factorized with the calculator to see if, just to go faster. In the exam, I would find the roots with the calculator and then write the sum working out, yeah? So 2 minus 5 minus 12, I get 4 and minus 3 halves. So I get 4 and minus 3 halves, which means we can factorize it as x minus 4 and 2x plus 3, yeah? This is our function. And if you look at these two factors, they are the same. So this is x minus 4 x minus 4 squared and 2x plus 3. So really, it has only two roots, which is the x equal 4 and the x equal minus 3 halves. Yeah, x equals 4 and x minus 3 halves. This one is going to be double, which means, so this one is the minus 3 halves, and this one is the 4. Remember, when I represent a cubic, in this case, coefficient of x cubed is positive, so it's going to go increasing instead of decreasing. This root is normal, so I go across, but this root is double, which means I touch, but it doesn't go across, it just kind of bounces, yeah? So this root is double, this root is single, yeah? So that's the way of saying that it has only two distinct roots, these two. Then figures 2 show a sketch of part of the curve. Deduce, given reasons for your answer, the number of real roots of this equation. If you compare this equation with this one, everything is the same except the number. So I have 48 and I have 46. So I would like you to think again on transformations and think, if we call this one gx, what is the relation between gx and fx? Yeah, and then you will see that gx is fx minus 2. Yeah, so I'm doing, I can write here, so I'm doing fx minus 2. And when I'm subtracting 2 to my whole function, everything is going down by 2. So this function here goes down by 2. This maximum goes down by 2, and this goes everything by 2. And it says the number of real roots of the equation. And you see that now I have 3 real roots. Yeah. So the way of explaining that is that this function is fx minus 2, so it's a translation in the vertical direction down, and that makes to have 3 roots instead of 2. Yeah, I'm not going to write that, do not take ages, but that's what is happening. So you're doing a translation of fx in the vertical direction to down, therefore you have now 3 solutions, because this one now goes completely across. Yeah. Given that k is a constant and the curve with equation y equals fx plus k pass through the origin, find the 2 possible values of k. Again, a transformation. I think sometimes you underestimate the power of transformations because it helps you with lots of questions. You have to remember what happens when we do f of x plus k. So we are adding k to the x. If you remember, we are going to translate our graph right or left. If k is positive, it's moving left. And if k is negative, it's moving right, which is kind of confusing. But if I'm moving my graph and it now pass the origin, is because this point, remember, was minus 1.5, no? And this point was 4. So I have 2 options to move my graph and pass the origin. Is the whole graph moves to the right. So I'm moving it right or left, right? I'm not amazing drawing them. I have moved it 1.5 to the right, and then it passed the origin. Can you see the other option? The other option is moving it left by 4. So this point here goes now to the origin. So I will have something like, this is going to be over. This up and then this down. Yeah. So this one is 4 left. Yeah. 4 left. 4 left means positive k. So k is 4. When k is 4, I move it left. This other option that was 1.5 right means k is minus 1.5. Can you see that? So remember, when I am adding a positive value of k, it's moving left. I know it's counterintuitive. And when it's negative, it's moving right. So if I move it left by 4, k is positive 4. If I move it right by 1.5, my k is minus 1.5. Yeah, and those are my possible values of k. You can do a sketch, but you can explain that this is a horizontal translation. Yeah, but those are the values of k. So k is 4 or k is minus 1.5. K is 4 or k is minus 1.5. Do you understand this question? This bit is sometimes a bit confusing to see. Yeah? Any questions? Do you need me to repeat anything? No? Okay, great. More. This one, a trigonometric equation. You couldn't miss that one. You're going to have trigonometric equation in your exam. And this is a super typical one. You have to prove an identity, and then you have to solve the equation. I would say this proving the identity sometimes are quite straightforward. Sometimes you start something, it doesn't work, and it's not unusual. So I would say don't panic. Maybe you come back later and try something different, because sometimes you substitute something, or you factorize, or you simplify, and it doesn't work, and then you try later and it works. But what I would say is, even if you're not able to do part A, you can do part B. So don't lose those marks, because this is the easy part. Yeah. Identity, 3 lines. I cannot move things right or left. I'm going to work with the left-hand side until I get the right, or with the right until I get the left, but don't move things around. Let's try with the left-hand side. So I have 10 sine, and always keep an eye on what you want to prove. Yeah, so see how it looks to simplify things. So look that I have a positive, a negative, a cos. It looks like I have simplified this denominator with something. Yeah. And I have a sine squared and a cos. So I would say the first intention, probably of all of you, will be substituting this by 1 minus cos squared. Yeah, so I have everything in cos and see what happens. So let's going to do that. This is going to be equal to 10, 1 minus cos squared, minus 7 cos theta plus 2. These questions can be tricky. I expand the bracket. So I have 10 minus 10 cos squared theta minus 7 cos theta plus 2. And I collect like terms. So I'm going to put the 10 and the 2 together. And I think you know where we are going. Yeah. So I have minus 10 cos squared theta minus 7 cos theta plus 12. And I'm almost sure that when we factorize this quadratic, because I have something and something squared, so I can solve it as a quadratic, I'm going to have one factor that is this one, so it can cancel, and the other is going to be this one. Yeah, always without doing it. So let's going to do with the calculator. I'm going to solve the quadratic. I have minus 10. Everyone sees that is a quadratic? Or someone is confused with that, with me saying that? I get 4/5. So one root is 5 cos theta minus 4, and the other root minus 3/2. So 2 cos theta plus 3, which means I'm going to cancel the 3 plus 2 cos theta with this one, and then I have the 5 cos theta minus 4. That's what I needed. The other way around. What I'm doing? Because of the minus at the front, no? So this one is the other way around. Oh, sorry. This one is the other way around because of the minus 10 at the front. So I have 4 minus 5 cos theta. Is that what we need? 4 minus 5, yeah. So 4 minus 5, 4 minus 5 cos theta. So this is the first part. We have worked with the left-hand side until we reach the right-hand side. Then, hence, I mean, this question is very important. We have to solve this equation between 0 and 360. What we are going to do is this part and this part are the same. And sometimes it's not exactly the same. And instead of theta, you have to theta, but it's almost the same. So what we're going to do is, as this expression is the same as this one, instead of this, we are going to use the easy one. Yeah. So let's going to use the easy one. 4 minus 5 cos. 4 minus 5 cos theta is going to be equal to 4 plus 3 sine. 4 plus 3 sine. And I'm going to solve this equation, which is much simpler. So the 4 and the 4 are gone, and I have minus 5 cos theta equal 3 sine theta. And I know that all of you are seeing that I have to divide by cos, or I can divide by cos. So I have tan. So I have minus 5 equal 3 tan theta. Yeah, so these two are gone, and sine divided by cos is tan, which means tan theta is minus 5/3. Calculator in degrees, and we find theta. So you find theta is tan minus 1 of minus 5/3. This is minus 59.036 degrees. This is the first solution, or the principal solution. It's the one the calculator gives you. But first of all, it's not in the interval. Yeah, my interval is between 0 and 360. And usually I will have more than one solutions. You can find the other solutions with the graph, the tan graph, tan cos graph, with the cast diagram, or with the circle. I like using the circle because I find I don't know, it makes more sense. But it's up to you what you use. So I have an angle here, which is minus 50 minus, remember when I measure clockwise is negative, so minus 59 degrees. Yeah. I need tan. And tan repeats every 180 because it's the gradient of this line. So really I'm talking about this line here. Yeah. This is going to be 59 again. So what other solutions I have that are between 0 and 360? This angle here, which is 180 minus 59. So 180 minus 59 point something, which is 120.96 degrees. So this angle here, I'm talking about this one. I hope everyone can see that, this one. And then this one as well. So I can go all around up to this angle because it's still below 360. And that angle is this one plus 180. Or if you prefer, 360 minus 59. Yeah, but remember the tan repeats every 180 degrees. I think that's right. If you don't remember, think. So the next one is going to be 300.96. Yeah, and they asked me to round to something, no? No, they don't. Solve the equation. So I'm going to round, I don't know, the numbers are so tempting to round. Okay, I'm going to round to whole numbers, yeah? 121 degrees and 301 degrees to the nearest degree. When you round, always write in brackets what you have round to, yeah, if they don't tell you. Or it's 3 significant figures if you want. Okay, is this clear? Have you seen how we solve it? It has, I don't think it's a complicated question, yeah? Okay, more. I think we are nearly done. We have a couple of questions more. Okay. This one, you have figure 3 shows a sketch of part of the curve with this equation. So it's a cubic, yeah? It's already drawn. Curve has a minimum turning point at x equals k. So here is this the minimum. Region R shaded is bounded by the curve, the x-axis, the line with equation x equals k. Show that the area is that value. Remember, we are going to integrate to find the area. We are going to integrate the curve that we have the equation between 0 and k. We need to find that k. And k is the x-coordinate of one of the stationary points, the minimum. So let's going to find the stationary points. To find the stationary points, we are going to derivate this function and make that equal to 0. So please, everyone differentiating. I have dy by dx is going to be, remember I multiply the coefficient and degree by down by 1, minus 34x plus 40. I'm going to make that equal to 0. So I have 3x squared minus 17x plus 20 equals 0. I'm going to get again with the calculator just to go faster. 3 minus 17 and 20. I have 4, so x minus 4 and 5/3. So 3x minus 5 equals 0, which means one maximum or minimum is the x equal 4, and the other one is 5/3. 5/3 is smaller than 4, yeah? Is 1 point something. So this is the value of the maximum, or the x of the maximum. This is the 5/3, and k is 4. Yeah, so I have two stationary points. One is the 5/3, which is here. The other is 4. Yeah, so I'm going to integrate between 0 and 4 this function. Yeah, let's going to integrate it very carefully. So the area is going to be equal to the integral between 0 and 4. And we don't have any problem with the graph going under or anything like that. Yep. 2x cubed minus 17x squared plus 40x dx, which is, I increase the degree by 1, so 2x to the power of 4 and divide by the new exponent, minus 16, I did increase by 1, divide by the new exponent, and then 40x increased by 1, divide by the new exponent, between 0 and 4. I'm going to simplify a bit the coefficients, yeah? So this one is going to be 2, and this one is going to be 20, and I'm going to write in the next page. So x to the power of 4 divided by 2, x to the power of 4 divided by 2, and then minus 17x cubed divided by 3, plus 20x, no? 20x squared. 20x squared between 0 and 4. And I'm just going to substitute first the 4. So I have 4 to the power of 4 divided by 2 minus 17 times 4 to the power of 3 divided by 3 plus 20 times 4 squared. That's the first part. And then minus 0, because I'm going to substitute 0, 0, 0. Yeah? And when you do this with the calculator, and very carefully, you get that value that they give you, 256 divided by 3. We can double check just in case. Has someone checked? $256.3. Yeah. So if you check with the calculator, you will see that you get that value. Okay. Next question. Everyone happy with that? Yeah. It was a very quick question for B9 integration question and 7 marks. It's not difficult. Another one. Modeling with exponentials. This can be a bit more difficult to understand. So the value of a car, V, in pounds, can be modeled by this equation. Yeah, and it's an exponential. I don't know if you can see, e to the power of minus 0.25 t, where the age of the car is t years and is positive. Using the model, find the initial value of the car. Initial value of the car is when t is 0, because we know t is the number of years. So let's going to make in that model t equal to 0. We are just going to sub in. V is going to be 15,700 e to the power of 0, because t is 0, plus 2300. E to the power of 0 is 1, and then we have 15,700 is what? 18,000, no? 18,000 pounds. Always write units when you have units. Yeah? Oh, sorry. So this is the initial value. I just substitute the t by 0, and I just find b. And be careful, because sometimes in this case it's just b in pounds. Sometimes they say in thousands of pounds, So be careful with those little things that can make your answer wrong. Yeah. Given that the model predicts that the value of the car is decreasing at a rate of 100 per years when t is t, we need to find, or we need to show this thing here. Do you remember well what it means, the rate, when it's talking about the rate? The rate of change is the derivative with respect to the time. So what is 500 is the derivative of this function with respect to time. Rate of change is d wherever by dt, and in this case is dv by dt. So we are going to differentiate that. T is going to be capital letter T, and then it's going to be equal to 500. And when we have that, from that, we are going to try to write this equation, yeah, which I think is immediate. So let me do it. So for B, first part, I'm going to do dv by dt. dv, remember, derivative of e to the power of a kt, the k goes to the front, but e to the power of something doesn't change, yeah? So I have this 0.25 negative multiplying this value, so I have minus 0.25 multiplying the 15,000. I have this value here, yeah? So minus, this is equal to minus 3925 e to the power of 0.25 t, capital letter T, because they ask us at that particular time. And then this bit, the derivative of the second part is 0, yeah, because it has no t. And that is equal, it says decreasing, which means this value is negative. And if you don't realize that, you still can see that you got a negative minus 3,900, and here is positive. So this is going to be equal to minus 500 because it's decreasing at a rate. So this number must be negative. Therefore, 3925 e to the power of minus. This value here is 500. Yeah? So that's what they are asking you to find. What you have to remember is when they ask about rate of change, is the derivative with respect to time. That's the key thing. Then, hence, find the age of the car at this instant, giving your answer in years and months to the nearest month. What they are asking us is to solve this equation. Yes? Can you try to solve it with me? We are going to solve this equation. So we are going to leave the e to the power of something alone. So we are going to put the numbers in the other side. I'm going to divide. So just dividing by the 3,900. So we have this thing here equal to 500 divided by the number. I'm not going to give the decimals because they are not nice. So I'm just going to leave the fraction. And then I'm going to take a ln, yeah? So taking ln in both sides, I have 157 means ln of e to the power of something is going to be the power of something. So that's 0.25t. And then I have ln 20 divided by 157, which means t is going to be this value divided by minus 0.25. And this value is going to be negative because it's the ln of a smaller number than 1. So you're going to get a positive value. Yeah, so let's do that. I get P is 8.24 to something else. Yeah, these are years, no? Years? What does it say? T is years, yeah? And we need to give the answer in years and months to the nearest month. So these are years, which means this is 8 years and 0.24 more years. If I want to convert the years into months, I need to multiply by 12. Yeah, don't think about the time that you multiply by 60. You're changing years in months. So we have 8 years, and then I multiply the 0.24 something because I'm keeping the number in the calculator. by 12. And I have 2.9, yeah? So 8 years, 2.9 months. But they say to the nearest month, so we are going to round that into 8 years, 3 months. Yeah? And that's when the car is decreasing at this rate. Yeah, that's what they're asking. When the car is decreasing at that rate of minus 500. Yes? Is it clear? Okay, perfect, perfect. And this is 6 marks because you have to solve the equation. Then the model predicts that the value of the car approaches but does not fall below a certain amount. State the value of A. There are a few ways of thinking of that. I would remind you how the graph of an exponential looks like, because I think it's going to help you. So remember, an exponential, when I have e to the power of a positive number, so e to the power of 2, for example, is doing this. Yeah, it's increasing exponentially. When I have a negative exponent, so e to the power of minus 2, if I have, for example, this, my graph is doing this way. Sorry, it's an asymptote, so it will go closer without change. Yeah, so, and what I have here is a number multiplying a function like that one, but then I am doing fx plus 2,300. Is this like the same that we did before? We have a reciprocal graph and then a transformation that is moving everything up. If it's moving up, my asymptote in the zero is going up to 2,300, which means this line is never going to go below 2,300. Yeah, so that's the minimum value that the car can have. I will become closer and closer and closer when the years pass, but that's going to be my minimum value. You can see with the graph, which I think is clear, or you can think of that this function is going to be always positive, but decreasing. So if you don't remember the graph, you have a value here divided by e to the power of 0.25t. When this increases and this decreases because you're dividing by a larger number. And then you are always adding the 2,300. So this becomes a tiny number plus the 2,300. So it's another way of seeing it. I think with the graph, I prefer the graph or with the function itself. Yeah, but the minimum value of the car with this model is 2,300. So I'm going to do in the next. So see, the minimum value is going to be 2,300 pounds. Yeah. Then state a limitation of this model, which is a very typical question about the models. Every time you have a modeling question, usually they ask you to think about a limitation, about a problem that the model have, and it's just 1 mark, and anything that you say that makes a bit of sense is going to be correct. Yeah, it's going to be marked as correct. Now, think that this will imply that the car at one point, even if it's super old, you still are going to get at least 2,300. And that could not be true. Maybe the car has a completely or an accident, or it breaks down completely, and you're not going to get 2,300. Yeah. So in real life, the car could be less than 2,300 pounds value. Yeah. You can write that with your own words or something very similar, and you're going to get the marks. Is the question okay? This one was a bit difficult, no? Okay, excellent. I see people. Some people are not saying anything. Are you okay? Are you understanding the question? Do you have any question? No? Okay. And we have, I think this is the last one. No, two more. Proof question. So given that n is a natural number, prove that n cubed plus 2 is not divisible by 8. Typical question, natural numbers, prove something. Your first instinct would be use proof by exhaustion. Remember, we prove for odd numbers, for example, and even numbers, and if this happens for both of them, then you have proof for all the numbers. So let's going to try that. Let's say that n is even. If n is even, I can write it as 2m. Yeah. If I do the cube of that, 2m to the power of 3 plus 2 is going to be 8m plus 2. 8m is multiple of 8. If I add 2 to a multiple of 8, it's not going to be a multiple of 8, yeah? Because the multiple of 8 goes every 8 numbers. So if I add 1, 2, 3, up to 7, it's not going to be a multiple of 8, yeah? The next multiple of 8 would be 8m plus 8. So 8m is multiple of 8, is multiple of 8, therefore 8m plus 2 is not, yeah? This is when n is even. When n is odd, and I would recommend you to write a lot in the proof questions. I'm not writing a lot for not taking a lot of time, but proof questions you have to write well your conclusions, your assumptions, your don't escatimate with writing things. If n is odd, that means I can write it as 2m plus 1. I'm going to cube that and add 2 and see what happens. To cube a binomial, you can use a binomial expansion, you can multiply the brackets, or you can use the Pascal's triangle. I like using the Pascal's triangle, remember, for the coefficients, sorry, because I think it's the fastest. So we are going to have the first one with the first coefficient to the power of 3. So I will have 2m to the power of 3. Then I will have the second coefficient with this one to the power of 2, and then times y by 1. The next coefficient 2m to the power of 1, and then the 1 squared, and then the last coefficient 1 cubed. Yeah. When I say 1, this 1 is this 1. Yeah. And then plus 2. This 2 is this one. If I write things a bit better, I have 8m cubed plus 12m squared. And then I have 2 times 3 plus 6m plus 3, no? 2 plus 1, 3. This is difficult to see if it's multiple of 8, but it's very easy to see that it's not a multiple of 2. It's not an even number because this first part is an even number. So I have this bit is an even number. This is even. And if I add 3 to an even number, it's going to be odd. And if it's odd, it cannot be multiple of 8. Yeah. So if it's multiple of 8, at least I have to divide by 2. So that would be a way of saying it. So it's not even. So it's odd. The whole thing is odd. Therefore, it's not multiple. Not multiple of. You should write more than me. Not multiple of 8. Yeah. So write the whole thing. The important thing is that you understand. So I have do for even numbers, I've done for odd numbers. In neither of them is multiple of 8, therefore it's not multiple of 8 for any number because they are odd or even. Yeah, that's a very, very typical example of proof by exhaustion. So proof by exhaustion is for all the type of numbers that you have. In this case, we are doing odd and even. Sometimes will be multiples of 3 and non-multiples of 3. Sometimes you will have 6 or 7 numbers, and then you try just for those 6 or 7 numbers. That's proof by exhaustion. Yeah. Question, okay? Will you have thought about this way of proving it? Yeah. Okay, one more, and I think this is the last one. Yeah, this is the last one. Two non-zero vectors, A and B, are such as magnitude of A plus B is A plus B. So magnitude of A plus magnitude of B. You have to think a bit on doing the sketches when you have vectors, yeah, because if not, the questions are sometimes difficult to see. Explain geometrically the significance of this statement. So you have, let's do a quick sketch. You have A. and you have b, for example, this, yeah, b. You know that when you add two vectors, you can put one after another. You put one after another, and you join the beginning of one with the end of the other, yeah? So this is a plus b. If the magnitude of this vector is the magnitude of this one plus the magnitude of this one, what do you think is happening? Because if I have a triangle, these two added together are going to be larger than this one. So what is happening is that my vectors are here. So this is going to be A, and this is going to be B. So they are going to be all parallel. If not, it's not possible that that happens, yeah? And I think the best way of seeing it is with a sketch. Geometrically, the significance of this statement is that A and B are parallel vectors or have the same direction or something like that. And then the next part says two different vectors, m and n, so now it has nothing to do with the a and b. M and n are such as magnitude of m is 3, magnitude of m minus n is 6, and the angle between vector m and vector n is 30. Find the angle between m and m minus n. I would like you to try to do a sketch before I do it of what we have. So we have a vector m, let's say m here, this is m, let's say, and this is n. The angle between them is 30 degrees. M is 3, so the magnitude of this one is 3. And then I have m minus n. When I subtract vectors, I just add the negative one. So if I'm doing m plus n, I would do this way. But if I'm doing m plus n, m minus n, I'm just going in the negative direction of n. So I am adding, I am doing m plus minus n, if that makes sense. Yeah? So I'm going down, and this is going to give me, I draw it, n should be larger. I think my drawing, n should be probably larger, yeah? And this is 30 degrees. I'm sorry because my drawing is not great. So this is minus n. I'm subtracting n, and that means that from here to here, this vector is m minus n. Yeah, because I have positive m and negative n, so m minus n. And this is 6. This is 6. So I have, if you look at this triangle, because I think is what is going to help you, you have one angle that is 30, one side that is 3, one side that is 6, the other that you don't have any idea, and they are asking you the angle between m and m minus n. So between m and m minus n, they are asking you about this angle. Let's call it alpha. And you know magnitudes. Magnitudes, angles, suddenly this is a triangle question instead of a vectors question, yeah? So we can use, I have two sides. I can use the sine rule. But if I use the sine rule, so let me do the drawing apart. This is 3, 30, and this is 6, and this is alpha. If I use the sine rule, I will be able to find this angle here. Yeah, but if I find this angle, let's call it beta, for example, using 180 minus the angles that I know, I will find this one. Yeah, but I think the best way is finding this angle with the sine rule because I have the opposite side and I have the angle on the opposite side. So let's do that. Sine 30 divided by the opposite side, which is 6. Yeah, sine 30 opposite is going to be sine beta divided by the opposite, which is 3. From here, I find beta. Yeah, so I'm going to do sine 30, which is 0.5 divided by 6 times by 3, and I do sine minus 1 of that. So sine beta is 1/4. Yeah, I'm going to do sine minus 1, which is 14.4755 degrees. That's beta, which means alpha, that is the angle that I'm looking for, is 180 minus 14.477 minus 30. So I have 135.52 degrees. Do I have to round to anything? In degrees, giving you answer in degrees to 1 decimal place. Okay, so the angle is going to be 135.5 degrees. And that's what they ask. I think the difficult part of this one is not the triangle. Once you have the triangle, it's just using the sine rule. And I'm sure you will think about that. Is seeing the whole thing that they are telling you. So you have vector m and n, vector m and n. You know the angle that they make. So m and n make 30 degrees. And you know m minus n. So somehow you have to draw in your script m minus n. So remember, when we subtract vectors, what we are doing is to add the negative one. So if this is n, minus n is the other way around. So I'm adding n plus minus n. And then the line that joins, or the vector that joins the beginning with the end, is m minus n. Yeah, the same that when I have a plus b, the line that joins, or the vector that joins the beginning with the end, is the a plus b. Yeah, I hope you can see that. Do you have any questions? No? Is the question okay? Or this one was confusing? Okay, I see thumbs up. I think that was the last one. That was the last one, yeah. No questions? No? You sure? Okay, then we are done. I'm very glad that you joined, and I hope it was helpful. If you have any question, please just tell me. You are still in time to tell me if you have any problems. Yeah? If not, I'll see you soon, hopefully. Bye-bye. Bye. Bye-bye.